Hello, I am 1A Block. This is Ben Martinez. Today I'm going to be talking about parametric equations. And instead of explaining what they are and doing that, I'm just going to go directly into an example, so it makes it just straight to the point. So I had this example set up. I set this up before this video started because it would have taken a while to draw this out. So this example is based on the movie Speed. And if you haven't seen the movie Speed, that movie is about a bus that has to go a certain miles per hour to be able to there's a bomb on the bus, and if they drop below the certain miles per hour, the bomb will explode, killing everyone in the bus. And spoiler alert everyone, the bomb, at some point they're on a freeway bridge and the bus begins to fall. They have to go off the bridge, and it's the end of the movie. The driver is sacrificing himself for everyone. It's very emotional. So this is based on that movie. So let's say that freeway bridge was 100 feet high, and so here's the little bus. It's my drawing of a bus, kind of looks like a burrito. Let's say this is 100 feet high in the air, and so I plotted that here on the y-axis as 100. So let's say that this bus, right before he goes off the bridge here, it's at 10. So x equals 10 when the bus is at the edge of the bridge. Now, what we're trying to find, with the parametric equations, we can find where, we can find based on the time, we can find where this bus is on the graph. So at 10, time is 0 because we're trying to find when the bus is falling. So if time is 0 here, we can then create our equations. So, and these are these are equations are based on time. So x as a function of time, equals the velocity. Let's just say the velocity is let's say the velocity is 50 feet per second. So x is a function of time, right? Then equals velocity, which is 50, times time, plus the starting point, which is 10. So this right here is where parametric equations get their name. This is called the parameter. Just rewrite that. Can't really see it very well. That is the parameter. And the parameter is usually time when talking about parametric equations, but it can be almost anything. So since we have this function, we can now make the function for y. So y as a function of time equals the original starting point on the y-axis, which would be 100 here, then plus the velocity of the y. So if this bus was going upward or going downward, but since it's doing neither, so if it was going upward or downward, since it's doing neither, we can't really say that it has a velocity going upward or downward on the y-axis. So that would just be left at 0. Then it would be plus again the gravity. So plus the gravity, and let's say like gravity is 9.8 meters per second. Let's just say that on this planet, whatever planet we're on, it is 30 feet per second. So this is gravity, 30 feet per second. But since it's going downward, since the gravity is going downward, we're going to say it's negative. So 100 minus 30, then times time squared over 2, which is a function that's used in parametric equations. I'm not sure where this, or it's a formula used in parametric equation. Not sure where this formula comes from or what the origins of this formula is, but this is a formula. So this would be the setup parametric equations, and using these we can find whatever point we want on this. So let's just say that at point, actually, so let's say we want to find how fast, what points this bus is at certain times. So I'd first set up a table for functions. So I'd say time is here, then we have the x and y. So time, let's say I'm not going to go too in depth into the time. So let's say time would go from 0 to 1 to 2. 0 to 1 to 2. So at 0, we already know that x is 10 and y is 100. We can see this if we go here. We can say x as a function of time equals 50 times 0 plus 10. And so that would mean that x equals 10, which is right here. So, and then we can do this also with the y function. So we say y as a function of time equals 100 minus 30 times 0 squared over 2, which equals 0, and then this 30 would then equal 0 again, making y equal 100. So from that, then we can see how this starts to come together. So if we want to find 1, we'd say x is a function of time. Let's bring in a new piece of paper here. X as a function of time equals 50 times 1 plus 10. Then this would equal 50 plus 10, making x equal 60. Then from there we would see what the y would be. So y as a function of time, oh my goodness, y as a function of time equals 100 minus 30 times 1 squared over 2. So 30 times 1/2 would equal 15. So equals 100 minus 15, which then would equal 85. So this would be the y coordinate. So at time 1, when time equals 1, x equals 60 and y equals 85. So let's write that down right in our graph here. So at time, I'll just like 90, 80, 70, 60, 50, 40, 30, 20, 10. Let's just say that this is the distance, like this is proper distance. And then, so here's 10. Let's say this is from 10, let's say just based on this, let's just say that this is 60 right here. Like, I know this is kind of like, that's no way that that would be the same distance, like here to 10 and this would be 60. But just for the sake of the problem, let's say that this is how it is. So here, about here would be time 1. So this would be t equals 1. This is where the bus would be in 1 second. So then let's just put it here in our graph again. So 60 and 85. Now let's find where it'd be at 2. So when I was going through editing, it seems that some of the footage that I had taken of solving for when t equals 2, it wasn't there, so I'm refilming this. So I had I just finished the problem, so I'll just pick up where I left off. So when we're solving for t equals 2, so t equals 2, we're going to find the function x as a function of time equals 50 times 2, which is 100, plus 10, which equals 110. So x would be 110 when time equals 2. Then for the y, when y as a function of time equals 100 minus 30 times 2 squared divided by 2. And 2 squared is 4, then divided by 2 would be 2. So 30 times 2 equals 60. 100 minus 60 equals 40. So y equals 40. So at time equals 2, the coordinate would be 110 and 40. Now, since this is a parametric equation, parametric equations create parabolas. So if you were to like put this parametric equation into a calculator, you would see how it would graph a parabola that would follow this same line, and then it'd go up again and down, blah blah blah. So with the points that we found for t1 and t2, or for time equals 1 and time equals 2, we could find, I drew a little line in a curve to show that this would make a parabola that would then continue, and then like this is where the truck would hit the ground. And so this is the basics of parametric equations. And thank you for watching. Hope this helps with studying for finals. Basically what you need to remember for parametric equations are how to set up the equations themselves. So we have, oops, wrong pen. Remember, 1, the equations. So they're usually seen in brackets like this. X as a function of time equals the parameter. And if you remember what the parameter is, that would be velocity times time plus starting x. That would be the equation to find x. Then y, it would be y as a function of time equals the beginning velocity of y. So if the so starting velocity of y, so if the object was moving up or down on the y-axis, so I just say v1, then starting velocity of y plus the starting velocity of y, then plus gravity, or it'd be the starting point of y. Here, let me just redo this. starting point of y, so 100, then plus the starting velocity of on the y-axis, so then this would be starting velocity of y, then plus again gravity, times t squared over 2. This is kind of messy. I'm just going to rewrite it right over here. Y as a function of time equals 100 plus beginning velocity of y, so if the object is moving up or down on the y-axis, plus gravity times t squared over 2. So this would be y. This would be how you would find y. And then second, you have to remember that parametric equations are parabolas, and they contain the parameter. So this is like a parametric equation creates a parabola, and also they have a parameter inside. That is the main thing. That this would be a good thing to memorize. Parametric, parabola, and parameter. Thank you for watching, and have a wonderful evening.